In this video, we're going to talk about the difference between an empirical formula and a molecular formula, as well as how to calculate both of those given a variety of different problems. So let's just first talk about something we're all familiar with, sugar. Okay? Most sugar that we consume goes by the chemical name of glucose, which has the chemical formula C6H12O6. Okay? Now, when we write a formula like this, we always refer to it as the molecular formula. A molecular formula is the actual formula of a compound. But today we're learning about something different. We're learning about something called the empirical formula. Because if we look at the ratio of these atoms, for every 6 carbons, there's 12 hydrogens and 6 oxygens. If you look at those numbers, we can actually reduce all of them. They can all be simplified. And in fact, if we simplified every single one of these, this comes down to a 1 to 2 to 1 ratio. So if we rewrote this formula in its simplified form, we would just have C1H2O1, which would also just be CH2O. So what I've written in here in blue would represent the empirical formula of glucose. So based on that, what is the definition of an empirical formula? An empirical formula is the simplest ratio of atoms in a formula. So CH2O, this can't be simplified. So therefore, since this can't be simplified anymore, this is the empirical formula. What that means is that for any compound in the world, there is one empirical formula for that compound. However, there can be many molecular formulas for the same empirical formula. So for example, if we took this empirical formula, let's write some molecular formulas for it. Well, the way we would do that is we just change the number of each atom while keeping the ratio of 1 to 2 to 1 the same. So we could have CH2O. We could have C2H4O2, because the ratio is still 1 of these for every 2 hydrogens for every 1 oxygen. We could have C3H6O3. We could have C4H8O4, on and on and on and on. We could have C6H12O6. Each one of these, every single one of these, is a different compound. They have different molecular masses, they'll have different reactivities, they'll have different intermolecular forces. But what do they all have in common? All of these guys have the same exact empirical formula. So what you need to know is the definition. An empirical formula, simplest ratio. Molecular formula can be any compound that has the same empirical formula. So let's look at some examples of how to solve problems where we need to figure out what the molecular or empirical formula is. So here's an example. A compound was analyzed and found to contain 13.5 grams of calcium, 10.8 grams of oxygen, and 0.675 grams of hydrogen. Now the issue is, as always in chemistry, we don't care about the mass of items. We care about the number of moles. So the first thing when we're figuring out an empirical formula is we have to determine the number of moles of each element present. So it's just a simple grams to moles conversion. So for calcium, we have 13.5 grams of calcium, and 1 mole of calcium has a mass of 40.1 grams. So that gives us 0.337 moles. So we can check that off. For oxygen, we have 10.8 grams of O. And 1 mole of O is 16 grams of O. Now I want to pause here real quick because we're so used to diatomic molecules, you might be thinking, Shar, why isn't it O2? I thought you said anytime oxygen exists, it exists as O2. Well, the thing is, in this compound, oxygen isn't just by itself. It's bonded to hydrogen and to calcium. So it's not just purely diatomic. It's going to be some ratio of oxygen atoms to the other ones. So in this case, it's not O2. It's not O2, it's just going to be left as O, so its mass is going to be 16. So if we do that math, we get 0.675 moles of oxygen. And last but not least, let's do our hydrogen. So we're given 0.675 grams of hydrogen. So same thing, it's not diatomic because it's bonded to other elements. So we know there's 1.01 grams of hydrogen for every 1 mole of hydrogen. So we do the math here, we get 0.668 moles. So what we have here is the ratio of how many moles of each element there are relative to each other in the formula, in this compound. Okay? But these aren't integers. You never see a formula written as like CA.337, O.675, etc. We always use integers. So to convert these to integers, this is the key point. So make a note of this. Once you have the number of moles of each compound, you need to divide every single number of moles by the lowest number of moles present. So what does that mean? Well, look at our 3 moles. Boom, boom. Which one is the lowest? 0.337. So we need to divide each one of these by 0.337 moles. So divide this by 0.337, divide this by 0.337, and divide this by 0.337. And then what we should get if we do the math, 337 divided by 337 is 1. For this it's 2. For this is about 1.98, which rounds to 2. So now we have some nice integer whole number ratios of each element to each other. So the last step to figure out the empirical formula, just write it. Well, for calcium, we know there's 1 atom of calcium, so Ca. For oxygen, there's going to be 2 O's, so O2. And for hydrogen, we know there's going to be 2 as well, H2. So boom, right here, this is the empirical formula for this compound based on the masses given. Key points, determine the number of moles of each, then divide by the lowest number of moles present, then write the formula. But let's say we're not given the number of grams of each. We're given percentages, like here. What do we do then? Well, part A asks us to calculate the empirical formula for NutraSweet, which is an artificial sweetener instead of sugar. What we're going to do is we're going to make an assumption. We're going to assume that we have 100 total grams of the substance. Because it doesn't tell us how much NutraSweet we have. We can choose whatever number we want. So let's assume 100 grams. And the reason we do that is because let's say we want to know the mass of carbon. Well, if I have 100 grams and 57.14% of it is carbon, that's easy to convert to a number. Because 57.14% of 100 is 57.14 grams. So for carbon, I have 57.14 grams. I'm going to convert to moles, so 12 grams of carbon for 1 mole. I'm going to do the same thing for hydrogen. I'm going to assume I have 6.16 grams of H. 1 mole of H is 1 gram. For nitrogen, it's 9.52 grams. 1 mole is 14 grams. And last but not least, oxygen. It is 27.18 grams. 1 mole, 27.18. Again, figure out the moles of each. So do the math. I get, let's start with oxygen. I get 1.698 moles of oxygen in this compound. For nitrogen, I get 0.68. For hydrogen, I get 6.16, and for carbon, I get 4.76. So, next step is the same as before. Exactly, I'm going to divide them all by the smallest number, which in this case is 0.68. Divide by 0.68, divide by 0.68, divide by 0.68. And now when I do the math here, I get 7, 9, 1, and 2.5. Great. So now I have the ratio for every single one of these. I have 7 carbons for 9 hydrogens for 1 nitrogen for 2.5 oxygens. Decimal. What do? We don't like seeing decimals in our formulas. So what I need to do is I need to multiply all of these numbers by something that will make them all a whole number, a whole integer. So what can I multiply them all by? Well, oxygen, 2.5. Let's multiply everything by 2. So now what I get is 14, 18, 2, and 5. So there we go. Now I have my whole number ratios. So the formula would be C14, H18, N2O5. There is my empirical formula. Boom. But now I want to figure out the molecular formula. That's what part B is asking. Find the molecular formula if the molar mass is 600 grams per mole. So the way we do this, to figure out the ratio of the molecular formula to the empirical formula, we take the molecular formula mass and we divide it by the empirical formula mass. And we get a number. So the molecular formula mass was given to us. It was 600 grams per mole. 600. The empirical formula mass was not given to us. Oh, but wait. We have the empirical formula right here. So we can figure out its molar mass using the periodic table. And if we do that, we get about 294. So if we do the division here, we get a whole number of about 2. So this means, what does this mean? It means that the molecular formula has 2 times the mass of the empirical formula. It also means that therefore the molecular formula must have 2 times the number of atoms in the same ratio as the empirical formula. So if our empirical formula was C14, H18, N2O5, this is empirical, we just have to multiply this thing by 2 to figure out what the molecular formula is. And so if we do that, we multiply all these times 2, we would get C28, H36, N4O10. Boom. That would be the molecular formula for NutraSweet. So if you're thinking back to today, you need to know what an empirical formula is, what a molecular formula is. You need to know how to determine both if you're given percentages or if you're given masses. And you also need to be able to figure out the molecular formula once you've solved for the empirical formula.